Hi, welcome to Praveen Daily. I'm going to post one video on embedded hardware design every day. So let's get started. The PCB material can affect the signal integrity of your high frequency circuits. You can minimize attenuation on your board by choosing the right PCB materials or substrate and copper foil. These two materials play a very important role when it comes to signal loss in your PCB. Signal loss comprises dielectric loss and copper loss. Dielectric materials are made up of polarized molecules. These molecules vibrate in the electric field generated by the time-varying signals on the signal traces. This heats up the dielectric and results in dielectric loss, part of signal losses. This signal losses increases its frequency. Signal loss can be minimized by using a material that has a lower dissipation factor. The higher the frequency, the more will be the loss in any given material. This is due to the change in electromagnetic field causing the molecules in the dielectric material to vibrate. The faster the molecule vibrates, there is more loss. Copper loss is essentially associated with current that flows through the conductors. Electrons may not always flow through the center of the conductors. The most of the current might flow through the surface layer of the conductor or a PCB trace. When an alternating current is passing through a conductor, the varying magnetic fields induce electric field known as eddy current. This induced electric field opposes the main current that is flowing through the center of the conductor but strengthens the current that is flowing outside on the outer surface of the conductor. As a result, there is an increase in current density on the conductor surface. This phenomena is called skin effect. The skin effect loss gets larger as frequency goes up. This can be compensated by increasing the width of the traces, which in turn creates larger surface area. Wider trace will always have lower skin effect loss. Earlier, copper was made rough to make a strong bond between the copper and substrate. Copper foil dielectric toothy interface profile increases the effective length and thus increases the copper loss. Skin depth effect reduces the effective cross section of the current varying or current carrying conductor. For conductors with a rough profile, a low skin depth causes the current flow through the counter of the material. This increases the length of the propagation path, as you can see on the screen. In order to mitigate this effect, it is always recommended to use low profile copper with good mechanical adhesion. So that's all we have for today's video. If you like it and if you don't want to miss tomorrow's videos, click on the subscribe button and let's meet tomorrow.